Good afternoon, students. Today we will going to discuss about isomerism and this naming of some compounds. So we have seen in yesterday class, that is nomenclature of coordination compounds, that is IUPAC rules. And here just we see some examples. So how to name this complex compound? So here first we have to, what is the rule? First cation followed by anion. So you know Cl contain minus charge, it is always anion. So this sphere should be contain cation. So means we have to name first this complex cation and then followed by anion. So in that we should name ligands first, then metal. So in what are the ligands? NH3 is there, water is there. So this is amine and the H2O is aqua. So which comes in alphabetical order first, amine will come first. So that's why we have to mention amine first, then aqua. How many are there? 3 are there. So triamine and then aqua. Next metal, chromium and metal oxidation number. So ammonia contains 0 neutral charge and water also neutral charge. So 3 Cl minus will have total minus 3. So this part is minus 3, means this sphere should contain plus 3. So that's why oxidation number is 3. Chloride. So this is anion. Next example, platinum ammonia taken 5, chlorine and Br3. So let us see. So this is the negative part and this sphere is all positive part here. So first we have to name positive part. So in that amine will come alphabetically first. Pentaamine, chloro and metal, platinum, and platinum oxidation number is 4. So because 3 bromines will have minus 3. So this part is minus 3. And here one Cl contain minus 1. So minus 1 and this part will contain plus 3 and here Cl will contain minus 1. Next one is, so this one, so this is contain minus 3. So this part is minus 3. So this sphere should contain plus 3. So and here one chlorine contain minus 1 charge. So to neutralize minus 1, it will have one more plus charge. So the platinum oxidation state is plus 4. So the sphere contains plus 3 but platinum oxidation state is plus 4. So we have mentioned in the brackets. And then negative part, bromide. So you should you should calculate the oxidation number correctly. Then only you can name the compound correctly. So the next example is platinum NH2 CH2 CH2 NH2 taken twice, Cl2 Cl. So this is nothing but ethylene diamine we have seen in the polydentate ligands. So bidentate, this is bidentate ligand. So this ligand contain in the name di. So that's why we have to mention the number by using bis like that. So that's why here we have used here bis. So in this ethylene diamine and chloro, which will come alphabetically first, chloro. So dichloro and here these are, how many are there? 2. Bis, ethylene diamine, platinum, metal is platinum and oxidation number is plus 4 because Cl2 will have minus 2, this part is minus 2. So sphere should contain plus 2. And here 2 chlorines negative ligands are there. So to neutralize this minus 2, it will have again plus 2 and plus 2 and here plus 2. Total plus 4 oxidation number. Chloride. So this is the naming of this compound. So this compound if you see, so here both cation and anion will have complex nature. So complex cation and complex anion. So how we can determine which is cation and which is anion? So here NH3 is a neutral ligand. So metal will have always positive charge. So that's why the sphere should contain positive charge. So that's why it is a positive part. And Cn minus. So Cn minus is a negative negative thing. So negative anion. So means after, so here after neutralizing this one, then minus charge will come outside. So that's why it is the complex anion. It is complex cation. So here the oxidation number of silver is +1. So how to name this cation part is first. So means in this ligand is amine, diamine, silver, and a silver oxidation number +1. And next in anion part, dicyano, silver. So this contain, so this sphere contain negative charge. So whenever complex ion will be complex anion, so we should end the metal name with 8. This already we have seen in the rules. Argentate, dicyanoargentate. For silver we will use argentate as the for negative complex anion, and oxidation number is +1. So this is some of the examples. And the next topic is isomerism. So we have seen in organic compounds isomerism. So in if we have more knowledge on isomerism in organic chemistry, then we can easily solve in inorganic chemistry also. So already we have seen in first year as isomerism means same molecular formula, so but differ in so and so. So let us see in coordination compounds. So in coordination compounds, isomerism is broadly classified into stereoisomerism and structural isomerism. So these are main two classifications: stereo isomerism, structural isomerism. So structural isomerism, first we will see about structural isomerism. So isomers are two or more compounds having same molecular formula but differ in their arrangement of atoms. So let us see structural isomerism. Structural isomerism means where they contain same molecular formula but they differ in structure. So let us see different types of structural isomerism. In that first one is ionization isomerism. So in the name only there. So ions will be different after ionization. So when we dissolve in water it will be ionized. So that ions will be different but molecular formula is same molecular formula but give different ions in solution on ionization. So when they undergo ionization, they will split into different ions but they have same molecular formula. So let us see the examples. Cobalt NH3 taken 5 Br SO4, cobalt NH3 taken 5 SO4 Br. So what is the difference here? So if you see, Br is inside the sphere and bromine is the outside the sphere. So means, so they differ, so they will give different ions on ionization but they have same molecular formula. So the name of this compound is pentaamine bromo cobalt plus 3 sulfate. So it will have two ionization isomers. So on ionization this will split into +2. So because SO4 is -2, this pair contain +2. And this will split into this ion. So this ion are different. So here sulfate and bromide are also different anions and different cations. So that's why it comes under ionization isomers. So ions are different on ionization. And next, how to differentiate them. So in laboratory, how we can differentiate which is this isomer, which is this isomer. So if two isomers are given to us, so which contains sulfate outside and which contains sulfate inside. So let us see. So for example, so this is the isomer, sulfate is outside. So we are testing is sulfate is outside or not. So let us add silver nitrate. If we add silver nitrate, so there is no precipitation. So because silver is precipitated by bromine. So but bromine is inside the sphere. So this will not dissociate into Br minus. So it is complex cation and sulfate is the complex anion. So if you add AgNO3 there is no precipitation. But if you add barium chloride BaCl2, So barium will have plus 2 and Cl will this part is have minus 2. So this barium plus 2 will form BaSO4 precipitate. So when we add barium chloride to this compound, it will give barium sulfate white PPT. So by forming white PPT, if white PPT is formed, then we can confirm that sulfate is outside. And let us check another isomer. So cobalt NH3 taken 5SO4Br. For example, this isomer. So if we add AgNO3, it can form silver bromide precipitate. It is a pale yellow precipitate. So if we add barium chloride to this solution, there is no PPT because sulfate is inside the sphere. It is a complex. It is in complex sphere. So but it cannot give the test for individual ion. So that is the difference between double salts and coordination complexes. So we have seen in the before class. So this is the complex compound. It will lose its identity on solute. So and adding so when we add water, it will lose its identity. So normal compounds will give individual ions, but complex compounds doesn't give individual ions. So they will give complex ions. Next, hydration isomerism. So let us see another type, hydration isomerism. So in the name only there, hydration. Hydration means addition of water. So water molecules will be differ inside and outside the sphere. So for example, if you see same molecular formula but differ in the number of water molecules of hydration, that is water molecules outside coordination sphere and inside coordination sphere. So the number of water molecules will be different in outside and inside the coordination sphere. Let us see example. So CrCl3 6H2O, we can write different isomers for this complex. So let us see. So CrH2O taken 6Cl. So here chromium water taken 6Cl3. So there are 6 water molecules, all are inside the sphere. But if you see this isomer, so we can write say for this same formula, we can write this many of isomers, hydration isomers. So chromium water taken 5 Cl and Cl2. Means here 5 water molecules inside the sphere and 1 is outside. So here 4 water molecules are inside the sphere and 2 are outside. So 3 are inside and 3 are outside. So we can, so if you see the number of water molecules will be differ inside and outside the sphere. This type of isomerism is called hydration isomerism, and these isomers are called hydration isomers. So and the next type is linkage isomerism. So this is exhibited by the complexes having ambidentate ligands. So we have seen in types of ligand ambidentate ligands. Ambidentate ligands means so they contain same structure. So ligand structure will be same but they differ in the dentate atoms. So for example, if you see, so here this is NO2 is the ambidentate ligand. So here this is linked by metal N bond, but here it is linked by oxygen atom. Here it is linked by nitrogen atom, it is linked by oxygen atom. So these type of ligands are called ambidentate ligands. So they can donate through different atoms. So let us see example. This is example. So here it is linked by nitrogen, here it is linked by oxygen. So these are two ambidentate ligands, but they contain same molecular formula. Both isomers will have same molecular formula, but they differ in the linkage. That's why they are called linkage isomers. So here this ligand is nitro, it is called nitro N, and this is called nitrito O. So it is yellow colored compound, it is red color compound. Means properties of the isomers are also different. So if the structure will be different, means linkage will be different, so their properties will also differ. Next, coordination isomerism. So coordination isomerism Isomerism can be seen in polynuclear complexes. So in polynuclear complexes, polynuclear means there are so many metals are there. So in the so many metals are there in polynuclear complexes, but they differ in the here ligands. They differ in ligands. So here chromium is the metal, and here also chromium is the metal, but here ammonias are there, here CN is there, thiocyanate. So they will exchange ligands. They can be formed by exchange of ligands. Let us see. So in polynuclear, so coordination isomerism is exhibited in polynuclear complexes where both cation and anion are complex. So both cation is complex here anion is also complex, but they have differ in ligands. So here ligands is different. For example, this is the complex, one complex, and this is another complex. Here 6 ammonias are there and 6 SCN thiocyanate ligands are there. But if we exchange these ligands, so ammonia taken 5, 1 SCN here, and SCN 5, 1 ammonia is here. So means it is formed by, this isomer is formed by exchange of ligands. So that is called coordination isomerism. And this is also. So cobalt NH3 taken 6, chromium oxalate taken thrice. So here oxalate is bidentate ligand, but ammonia is monodentate ligand. So how we can write the isomer to the here? So instead of 2 ammonias, we can write only 1 oxalate because it is bidentate and ammonia is monodentate. So we can replace 2 ammonia molecules by 1 oxalate. So NH3 taken 4, 1 oxalate here and 2 ammonias here. So we can write isomer like this. So next, stereoisomerism. So stereoisomerism means isomers that have the same connectivity. So bond connectivity is same but differ in the arrangement of atoms in space. For example, here A is there. So A is the nucleus, and here B, C. But here in this isomer, so here C, here B, for example. So this, what is the difference here? Connectivity is same. So A is connected to C and A is connected to B. A is connected to B and A is connected to C. Connectivity is same, but the position of C in space is different. Means here it is in right side, it is in left side. So both are differ in the position of C. So that is called stereoisomerism. Isomers that have the same connectivity but differ in arrangement of atoms in space. So let us see, the stereoisomerism is classified into geometrical isomerism and optical isomerism. So geometrical isomerism means cis and trans. So for example, this is the geometrical isomerism. Here metal, so chlorines, 2 chlorines are in same side, and here 2 chlorines are in opposite side, but they contain same molecular formula. PT, NH3 taken twice, Cl taken twice, Cl2. So this cis isomer, the same side contain isomer is called cis isomer, and this is the trans isomer. So same molecular formula but differ in position of ligands in space. So here the chlorines are on same side, they contain in 90 degrees angle, but here 180 degrees angle. So they differ in the position in space. So these are non-mirror images and non-superimposable. So what is mean by non-mirror images and non-superimposable? So they are not mirror images. For example, if you see these hands, so they are mirror images. Means we can see in the mirror same, like the same. So but here if you see, they are not mirror images. See ammonia, and here ammonia, and here chlorine is there. So they are not mirror images and they are not superimposable. What is mean by superimposable? For example, if you see, so if you put like this, so there is different. So this is called non-superimposable. So superimposable means if you put like this, so this is the superimposable. So this is non-superimposable. So if you put this compound on this compound, exactly same. So if you put this compound on this compound, so here chlorine and chlorine is there, but here ammonia is there, okay, but here in place of chlorine ammonia is there. and in place of ammonia chlorine is there. That is called non superimposable. So these are non mirror images and non superimposable isomers.